Hello, warm wishes to all. On this month, we are going to see about some different topics. Today, we are going to see about a new topic. It's called that is AlexNet. Already, we discussed a lot of the parameters related with deep learning. So, this is also one part of that deep learning. That's the CNN, that is convolution neural networks. So AlexNet is one part of convolution neural networks. Instead of using the word part, it's adding the certain advantages to the existing and standard convolution neural networks. So before getting into the core concept of that AlexNet, just I want to share a little bit introduction about that AlexNet. So AlexNet is a convolution neural network architecture that's purely developed for that image classification task. Already we know the CNN that has been used for image classification and then image identification, and also we learned in previous episodes about that is the GAN networks also. So this is also that is image classification, but it's having certain advantages rather than that convolution neural networks. In that coming episodes or in the next episode, we have to see how this AlexNet is giving more advantage rather than convolution neural networks. And this AlexNet notably having the prominent through its performance like in the ImageNet. Already we know, so what is that ImageNet. So if we are saying that ImageNet, it is a project. It's having a large visual database that is designed for use in visual object recognition. That's software for the research work. And the ImageNet having more than 14 million images that is annotated purely for their project purposes and then R&D purposes. This ImageNet having a large scale visual recognition challenge. So we say ILSVRC. So and it classifies as images into 1000 distinct object categories, and is also regarded as the first recognized application for deep convolution networks in large scale environment. So now we have to come to the introduction part of that AlexNet. This AlexNet that is developed in the year of 2012, that's by the name that is that Alex Kriswisky with a collaboration of Sutzker and his PhD advisor along with Geoffrey at that University of Toronto, and they developed this model, and for their testing purpose they had 60 million parameters, 60 M parameters they had, and they used around some 6,50,000 of that neurons, and also automatically for handling this kind of images, obviously we need that is that GPUs, that is the graphics processing unit, and they are using the appropriate GPUs for the performance escalation. And the architecture mainly influenced a good name for that AlexNet. In the previous years, and the people are using that CNN. But in that CNN, the people faced certain disadvantages, and that CNN wouldn't able to produce expected and then more accuracy of that outcome. So the researchers continually work on to improve that CNN. So by this way, they got that is one beautiful method. It is called that is that AlexNet. Now we have to be see about a quick view on the architecture of that AlexNet. So that will give a little bit input for us. So this is the architecture. Already we saw these parameters of how it's having. The architecture mainly the AlexNet, it's having 5 convolution layer and then 3 fully connected layers. So when we are saying the convolution layer means already we know these things. The convolution layer, it's having the max pooling. Every convolution layer, it's having that certain pooling layers, and the last three layers we are having the fully connected layers. Okay, so on the CNN convolution layer we are having the activation function. Since this CNN, it's working under the non-linearity, and then obviously we have to go for rectified logic unit, that is ReLU activation. Already we know these concepts in that earlier episode we discussed under the category of the deep learning. In case if you won't be well aware of what is that ReLU, please visit to the previous episodes. There you can able to be find that appropriate definition for that ReLU. So on this moment, let me share that is one pinpoint is that ReLU implemented to handle the non-linearity among the data set. Since the convolution layer is working on that images, obviously we have to be work with that non-linearity. So to handling that non-linearity, we need that is that ReLU activation. So the convolution layer, already we know it's having that two part, that is first one ReLU activation layer for that non-linearity, and another one that is that max pooling layer. So max pooling layer we did that is the two parameters. One is we have to be extract that is the maximum value of that small segment, otherwise we have to compute that average of the particular small segment. So these are all the fundamental concepts. And then the next one we are having the fully connected layers. So these fully connected layers along with that ReLU, so this is giving the appropriate outcome also. And there the AlexNet using the method is called that is the softmax. So in fully connected layer that has been implemented with that softmax. In previous CNNs there you may use that is a sigmoid or that tangent. So this kind of that function may be used, but in AlexNet the fully connected layer is implemented with that softmax. So this is the structure and then the basic parameters of the CNN. And now, so this is the simple architecture. So what I said earlier, it's having the 5 convolution neural networks, and it's having the 3 fully connected networks. On whole, the AlexNet has 8 layers. So in that 8 layers, we are having the 5 convolution layers, and we are having the 3 fully connected layers.